thanks for coming. And we're here to, as a lab, to learn how to talk with the press. One thing to remember is that when you're talking to the press, you're talking to your mother's friends.
Turbulent water immediately loses energy and everything starts to fall out of suspension, and it falls in such a way that the coarsest material ends up at the bottom, the heaviest ether. The sand and mud is all being carried in that water. You can see how much the sand and mud is carried in suspension. So the sand and mud is being carried by the water, but you can also see that as soon as I stop shaking the jar, I'll shake it the way where the largest pieces are on the bottom and the smallest pieces are on the top. Also our water, and in this particular case, it's a little more complicated. There's a lot of sand and mud that's sitting in between them that's all the same size.
Fatima, I brought you here today because we just had a magnitude 4.7 earthquake 17 hours ago in Oklahoma.
Saltwater disposal is causing thousands or setting up thousands of these earthquakes. We are monitoring these earthquakes in our lab. They think all these earthquakes are induced by hydrated fracking. We see some small earthquakes from fracking, but most of these large earthquakes are caused by injecting saltwater disposal.
Let's pretend that this is like a really big version of a fiber optic cable, like just the kind that you would have, you know, for telecom. And let's say that I have a car drive by, then what happens is the fiber starts to wiggle and it kind of rotates in this motion. And I pick up a lot of that actually. So we have a specialized kind of laser that we use for detecting the seismic signals, but it's not that different from what people do when they're actually sending telecom signals.
Or did it relieve the stress on the nearby portion?
Okay, I see. So stress was relieved along that section of the San Andreas Fault. And I've actually got a model of that right here.
Let me see.
So the San Andreas Fault is a right lateral fault which pull these blocks in the sense of motion along the San Andreas. You can see it's slowly moving.
Yes.
And then as it gets to this bend, compression between these two blocks. So they're locked, and then if I pull harder.
Oh yeah, that's going. Oh, fantastic.
There we go. And so it's hard to see, you know, but in the scale of...
Yeah, no, it's not hard to see.
Well, from the research that we've been doing on the giant sequoias, so far actually have mechanisms that allow them to survive and persist during a drought. Seen many droughts in their lifetime. Climate change has increased the probability of droughts occurring in the future, and in particular that droughts will be even drier than they've been in the past. So this runs a risk of exposing these giant sequoias to conditions that they've never seen before, and we really don't know, we really can't predict how they're going to respond to that.
I think there's about 10 or 12 in there.
In this ground soil? Well, you can see how sick you get if you eat it. No. There's actually 1 billion microbes in this gram of soil.
That is unbelievable.
So the biomass of the amount of microbial biomass in the soil exponentially decays. Most of them are at the very top.
All right, now I'm going to stop you.
Okay.
Exponentially.
Okay.
Emergency!
This is what we call a right lateral strike slip fault, which means that if I'm standing on this side of the fault, I'll see the other side move to the right relative to me, down relative to the other. And it's a little harder to show with this model, but we also have a thrust fault, where one block might move. I knocked down my fence here over another. But faults don't just come in these three flavors.
I thank you all for this experience, and I hope putting you in the hot seat gave you a taste for what it's about.